Hello and welcome to Maths 205 Abstract Algebra 1. I'm Imam, a lecturer at the Department of Mathematics, Ahmad Bello University, Zaria. This is a 200 level first semester course, 3 credit unit. And in this course, we are going to introduce a concept in abstract algebra. So this is lecture 0, and it's going to be an introductory lecture and giving a course overview. So introduction. Abstract algebra is an aspect of pure mathematics that studies mathematical systems such as groups, rings, fields, and other algebraic structures. And by mathematical system here, we mean a set together with some binary operation. And the way abstract algebra studies these abstract mathematical systems is by focusing on the underlying structure and rules of operation rather than specific numbers or objects in the system. So this is actually the goal of abstract algebra. It is to study systems, namely sets. These systems are mostly sets together with some rule of combination of elements in the sets. And the interest is to expose the underlying structure, the hidden structure behind these systems, along with the rules of combination, and also to study how elements within the system interact. And so this course is the first course in abstract algebra at undergraduate level, at least here in the Department of Mathematics, Ahmad Bello University, Zaria. So being the first course, it is the foundational course in pure mathematics. So it's one of the foundational course in pure mathematics, and therefore the course is crucial for developing a higher level of mathematical maturity. So in fact, this course is the first course that is required to prepare students to becoming mathematicians. So actually, you cannot just help learning mathematics without having to have a very good understanding of this particular course, Maths 205. In fact, this is the foundation of the pure mathematics itself. And in this course, as we are going to see, we shall also talk about the very foundation of mathematics, which is logic and sets. Unlike earlier courses that focused on computational techniques, this course emphasizes on structures, logical reasoning, proofs, and abstractions. So this is mostly what we are going to be talking about. So this course differs in many ways from the other courses that you have gone through. In the first year of your study, you have seen calculus, where you are differentiating function and also integrating functions, and also you see courses like elementary algebra, where you are having to do with solutions of quadratic equations and equations of degree 3 and so on, talking about permutations and combinations. All these ones are computational issues. But abstract algebra, and this course in particular, Maths 205, will focus on structures, logical reasonings. So we are going to talk a lot about logic because we have to formalize the language, and we'll talk about proofs, that is verification of whether an argument is valid or not. And then we'll also introduce some concept of abstractions. We are going to talk about the concept of group in this course. So this is the first course that will introduce students to pure mathematics. And so why is abstract algebra important? Why do we need to study abstract algebra? So abstract algebra, when we go back into the history, the subject emerged from an attempt to solve polynomial equations and also attempt to study symmetries in geometry and formalize number system. That is the root. Initially, it was all about solving equations, and this is what the ancient mathematicians do. They are mostly interested in solving equations. Babylonian always interested in solving equations, polynomial equation in a number of variables, finding whether solutions exist to a certain equations. And so it started with the work of Galois or Abel and Galois, studying root of polynomials and showing that a certain polynomial has no root. And then he used some element of what we call group theory today. And that is the beginning, mostly. And in studying symmetries, it so happened that when you are looking at the symmetries of a particular object, the collection of all the symmetries is forming a group. So initially, the study of abstract algebra was motivated in mathematics, in solving polynomial equations, and also in studies in geometry of symmetries, and also looking at properties of numbers and so on. But then recently, abstract algebra found application in areas like cryptography. That is an aspect of science that has to do with securing digital communications. We are now seeing applications of abstract algebra in these areas, and also in coding theory, error detection, correction in data transmission, in computer science, in algorithms, in logic designs. Abstract algebra has found applications. Without abstract algebra, all these things wouldn't have been possible to be in existence. In physics, sciences, like studying symmetries, symmetry group has found application in quantum mechanics, mathematical biology and economics, many other areas of science and social sciences, and even in engineering. Abstract algebra has found application. So that is why it is very crucial to develop the theory. But then we have to go back into the beginning and make the student be familiar with how the whole subject started. So just to give you an overview of what we are going to be talking about, this course will be structured or divided into 4 main parts or chapters. The first chapter of the course will talk about logic, and then we'll cover under this chapter what we call sentential logic. Statement, propositions will be defined, and then we'll also talk about connectives. And these are some of the operations that are used to combine statements to produce other statements. We'll talk about truth tables, propositions, tautologies, and contradictions. And then we'll look at logical equivalences and implications. All this will be treated under chapter 1, logic. And then the second chapter, then we'll also talk about predicates and quantifiers, still under chapter 1. And then the second chapter of the course, we will focus on method of proof, proving validity of argument. Adiomatic systems. We'll introduce the concept of adiomatic systems, arguments, and formal proofs. And then we'll talk about direct proofs, indirect proof, proof by contradictions, contrapositive proof, and natural deductions. So these 2 chapters will form the foundation of the language. We are going to actually clear ground for the language. This will prepare us for the language of presenting mathematics in general. So and in the 3rd chapter, we will start talking about algebraic structures. Like the Boolean algebra will be the first algebraic structure that we will talk about, and then we'll look at basic definitions of Boolean variables, operations, and so on. And then we'll also look at axioms and simple theorems and application to computer science, digital circuits, and logic. And then elementary notions of group. This is the second aspect of abstract algebraic objects that we are going to look at, which is a very fundamental object in abstract algebra, and a very basic one, group. So we are going to introduce the notion of group. We'll define binary operations and algebraic structures. We'll talk about properties of binary operation like closure, associativity, identity, and inverses of elements. And then we'll define the notion of semi-group, monoid, and groups. We will exemplify all these concepts using integers under addition, non-zero rational numbers under multiplication. And then still under the same chapter on elementary notion of groups, we are going to talk about symmetric groups of degree n. It's a very basic and fundamental object, the notion of permutations and permutation groups. And then we will talk about symmetries of regular polygons. So this is what we are going to cover in this course, 4 chapters, and then we will go through it one after the other. So learning outcome. By the end of this course, a student should be able to distinguish between statement and non-statement, because it's not every sentence in English or in a language that is recognized as a statement in mathematics. So we are going to talk about what that means. And then student should be able to use connectives, quantifiers, truth tables to analyze logical statement. Student should be able to apply direct and indirect methods to construct valid proof, to define Boolean algebra and apply it to simple theorems, recognize the role of Boolean algebra in computer science and circuit design. And also, by the end of the course, students should be able to design and identify binary operations, semi-groups, and groups. So by the end of the course, we expect a student to know what all these terminologies are. Verify whether a given set with an operation forms a group, to work with permutations and symmetry groups. Students should be able to develop precisions in mathematical reasonings. And this will now, this is where the aspect of mathematical maturity, that is understanding of mathematical language, to develop precision in mathematical reasoning, to communicate mathematical ideas using proper notations and logical flows. So this course is actually very, very, very crucial, because we have seen that many students don't know even how to write some mathematical concept. Sometimes you have these concept ideas in your mind, but you don't know how to put them down. So we'll learn a lot about how to translate ideas or English statement into mathematical formulations. And students should appreciate abstraction as a unifying theme in modern mathematics. So this is what we expect as the learning outcome for the course. We will go through this concept, the course content as we have presented, one after the other. So this lecture is actually just an introductory lecture. So in the next discussion, we are going to start talking about the very first chapter of the course, which is logic, and then we'll start talking about what a statement, proposition, and logical connectives are. Thank you very much for being with us, and I hope to see you in the next lecture. Please don't forget to subscribe to our YouTube channel so that you can follow the series. Thank you very much.